let's look at trying to find the area of this triangle. I know that the area of a triangle is going to be based on 1/2 times the base times the height. And if I keep this triangle in this orientation, I've got a base pretty clearly set up. So I've got the area is 1/2 times 200 times the height. But what I don't have is the height. So let's draw an altitude. And I'm going to call this altitude h for height, very original. And suddenly, as soon as I do this, I can see that I have some right triangle stuff going on here, and I can use some trig for that. Recognizing this angle is 60, I can then take a look at this in terms of trying to get the height based on this shape. And when I do that, we've got the opposite, the hypotenuse. Sorry, it's another h. I'll use capital 1 for that one. And there's my adjacent. I'm trying to get the hypotenuse, trying to get the opposite. That's the h issue. And I know the hypotenuse. Let's use sine. So we're going to have sine of 60 multiply, or is equal to, rather, that height divided by 100. So my height is going to be 100 times sine of 60. If I literally plug this into my area formula, I've got the area is equal to 1/2 times 200 times 100 sine of 60. And again, for all purposes, you're done here. If you'd like to get a decimal for this, this is 0.8660. So we end up with 100 times 0.8660, which is going to end up being 2 spaces, so 86.6. So we've got area is 1/2 times 200, which is 100, times 86.6, and that gives us 8660. And I have no idea what these units are, so we're good. You may also have noticed this happens to be a 30, 60, 90 right triangle, although I did not realize that when I made that. So you have some other ways that you might get to this too. But this is the way we're going to talk about for this.